So you might be asking yourselves, these curve sketching problems seem really long. Does he really expect us to do one of these on the test in addition to all the other types of problems that we've been seeing in this applications of derivative portion of the course? Well, yes and no. I don't necessarily expect to just give you a function and expect you to go through the entire process and then create a table and then go to the graph. The process of analyzing the function, we're doing little bits and pieces, and you'll see those on your test in little bits and pieces. I'll ask you to tell me where a function is increasing or decreasing, or I'll ask you where a function has its inflection points, things like that. In terms of a test question over curve sketching, what I would do is give you a table and a graphing grid like you see in front of you here in this video and ask you to use that information to actually create the graph. So the analysis has been done for you and the information has been taken and summarized into a table for you. You just need to figure out what to do with it. So let's see what we can do with this table of information here. So the first thing I'm going to do is plot some points. So I have an x-intercept at 0, 0. And I have an x-intercept at 4, 0. So I'm going to try to put some nice big green points on here. Y-intercept is also 0, 0. And if I look down through my table here, it looks like something happens at the point 1 and negative 27. So 1 and negative 27 for me is right down here. All right, notice my scale. Every fourth box is 1, so each of these boxes is a quarter on the horizontal axis, and every box is exactly 1 on the vertical axis. There's also something going on at 2 and negative 16, so I'll need to come down to, looks like right here, or is it one more? 20, 19, 18, 17, 16, one more right there. And I am 1, 2, 3, 4, 5, 6, 7, 8 over, so that is correct. And then something happens at 4 and 0, I've already seen that. So from negative infinity to 1, this thing is decreasing, and it's going to be concave up. So that might be a little bit difficult to draw here because there's not a lot of room here. But if I look further, at x equal to 1, I'm going to get a relative minimum. We're going to be concave up. So relative minimum implies that I'm going to have to do something like this, come down, and then I've got to go back up through that point there. So we're going to get something like that, trying to keep it concave up the whole way. Now at 2 and negative 16, I'm going to be concave up all the way to there. That's an inflection point. So we want to keep this concave up to that point. And then we're going to change our concavity and go back the other way until we get to 4 and 0. Then our concavity is going to change again. We're going to go up kind of like this. So these are kind of hard to draw, and my drawing on my computer screen is usually a little bit more difficult, but I can definitely see that I look concave up down through here, and I keep that up. Oops. I'll try to sketch this in a little darker here. And then at 2 and negative 16, I'm definitely going to change my concavity. I'm going to kind of roll over and start to increase in this way. And then at 4 and 0, I'm going to make sure my concavity changes again. And I start to increase in this direction. And that satisfies everything. I've got my x-intercepts, I've got my y-intercepts. There are no asymptotes for this function. We are concave up and decreasing down to the point 1 and negative 27. That's a relative minimum. Then we're concave up and increasing to the point 2 and negative 16, which is an inflection point. Concavity changes. We're still increasing, but now concave down. We hit a new inflection point, and we are now concave up and increasing. Now it looks like the derivative at 0, the first derivative at x equal to 4, excuse me. So the first derivative at x equal to 4 is also 0. So this should have flattened out probably a little bit more as I came through here. And I could probably fix that a little bit. But I think we get the general idea. That's the kind of question that you should be prepared to do for a grade for me coming out of the curve sketching section. Now you will be asked to do complete problems like these in the WebAssign, but just a couple, not too many, because I understand that they are rather lengthy.